at the time. So that was the case that what are block ciphers, what are stream ciphers, and now directly go towards the first modern cipher what we people are going to learn, that is DS, data encryption standard. So stream ciphers messages a beat or a byte at a time to do encryption decryption. Many current ciphers are block ciphers. So it is considered that modern ciphers are mostly block ciphers. Hence, the focus of this chapter is on modern ciphers. Now, in which case stream ciphers are needed and in which case block ciphers are needed? If you will concentrate on online data generation, means online processing of data, at that time the data is gradually coming and it has to be processed on the spot. So whenever urgency of encryption of data is there, always we are using stream ciphers. But when the block of data, means it is not needed that on the spot when the data is coming, you should do the encryption decryption at that time. What normally we are using is block cipher. So block cipher are used in case of large amount of data has to be encrypted, as well as urgency of data is not there. But whenever online processing means what? Real time processing of data is needed. As and when data is coming, it has to be encrypted and then it has to be forwarded back. So in those cases, what we are using is stream ciphers. So streams of data, as and when it is coming, just do the encryption and then provide it further or processes further. So as far as block ciphers are concerned, we have seen that Feistel structure was the standard structure which was used in case of block cipher. So block ciphers, you are having 64-bit block. So in case of extremely large substitution, it is considered as you are having extremely large substitution. It is not on place of A, you are having P. In classical cipher like monoalphabetic, we have seen that in case of A, we are having P. In case of B, you are having Z. So this is one by one or character by character substitution. Instead of that, you are having block by block substitution. So if my block size is 64-bit, then how many ciphertext beats are possible? So you can say that 2 raised to 64 entries are there in case of table, which are nothing but corresponding substitution of this 64-bit. So are you getting? It is very hard for doing brute force attack on any block cipher, because the minimum length of block, if it is considered as 64-bit, 64-bit, 128-bit, 256-bit, 512-bit. So these are the block size what we will see in modern cipher. So if the block length itself is a very huge number, then brute force attack in which you should have entry for each and every plain text and the corresponding ciphertext. So because of that, 2 raised to 64 minimum entries are needed in the table in which you are having mapping of plain text to ciphertext. So because of that, it is considered that arbitrarily reversible substitution cipher for a large block of this is not at all practical. So arbitrarily reversible means what? From the ciphertext, if I want to get the plain text back. So if I want to get the plain text back, what will happen? Now the problem with this cipher, the problem with block cipher is what? If I want to get here, what will happen? You should have a large amount of entries. So this large amount of entries are very hard to be done. So because of that, here it is considered that 64-bit substitution block cipher, the key size is 2 raised to 65. So it is a huge, you can say that from brute force or any analytical crypt analytical point of view, it is very hard to break modern ciphers, because at a time the block size what is considered is minimum 64-bit. So because of that, the basic principle or the structure through which block cipher came into existence was one of the structure which is Feistel cipher structure. So today we will understand this Feistel cipher structure, how exactly it is working. And once you will do the encryption process using the Feistel cipher, likewise you are having decryption process or decryption of the ciphertext to get the plain text back. So Claude Shannon, as I told you that in 1950s, Claude Shannon has proposed this SP network or SP cipher, which is nothing but substitution permutation cipher. And this are nothing but S boxes and P boxes. We will learn in depth what is the meaning of S box and what is the meaning of P box. Just the, you can say abbreviation for S is nothing but substitution. Abbreviation for P is nothing but permutation. So permutation indirectly it is nothing but transposition. So as transposition and permutation, in previous lecture it is specified that combination of both the things were creating a cipher which is most robust. So this principle is used in SP network, and that was proposed by Klaus Shannon in 1949. So using this, it was specified that confusion and diffusion of messages must be there. So what was the meaning of confusion and diffusion? So the process of the introduced by Cloud Shannon, the meaning of diffusion and confusion is statistically it should be very hard to get the plain text from the ciphertext. So cryptanalysis based on the statistical analysis should be as tough as possible. So assume the attacker has some knowledge of the statistical characteristic of the plain text. As in previous lecture, we have seen that cryptanalysis using known plain text is possible. So known plain text, what it signifies that if known plain text is there, that information is there with the attacker, then to using the diffusion and confusion property of proposed by Cloud Shannon, it should not be possible to get the plain text back from the ciphertext. So ciphertext needs to completely obscure the statistical properties of original message. So whatever original message plain text is there, it should not affect the corresponding ciphertext characters. So that was nothing but one-time pad does this. So one-time pad, as I told you, that practically it is more not possible to implement one-time pad. But what it secure is there is no relationship between ciphertext and plain text in case of one-time pad. So diffusion and confusion property in previous lecture we have seen that what is the meaning of diffusion? Diffusion means dissolve. Dissolve what you want to dissolve. The plain text has to be dissolved in ciphertext. So ciphertext can be considered as water, plain text can be considered as some powder or detergent. So detergent, each and every drop of detergent should be mixed with multiple drops of water. So that is nothing but diffusion. So just using an example, it would be very easy for you to explain what is this property of diffusion. So what it says that multiple ciphertext beat or bulk of ciphertext beat has to be implicated from one plain text beat. So a single plain text beat is affecting multiple ciphertext beat. Then if this is satisfied, then it is considered as diffusion property of any modern cipher. So it is having the rule diffusion. It signifies that dissipate the statistical structure of plain text over bulk of cipher text. So statistical structure means what? A single beat of plain text affecting multiple ciphertext beats. And confusion. Confusion means what? The relationship should be as hard as possible. But between which two things? The relationship between key and ciphertext must be as hard as possible, as complex as possible. This is nothing but confusion. So make the relationship between ciphertext and the key as complex as possible. So this too, Cloud Shannon has specified in 1945 that if we want to develop any modern cipher, these two things are to be taken care of: the property of confusion and the property of diffusion. So the Feistel structure, which was a standard structure adapted by all the modern cipher, how it is working, how it is working. So just see this, that as Shannon has specified that it is working on which principle? SP network. It is working on SP network SNP. SNP, what it signifies that you are having substitution property and you are having permutation property. So substitution, permutation, both the things are considered together. So when we are considering it together at that time, what type of things are possible? So now see this, that if Feistel cipher is designed like this, then exactly what is happening in case of Feistel cipher. So modern cipher DES, AES, triple DES, all are using this. So if you are learning DES properly, other ciphers, modern cipher would be easy for you to understand. So now see this, that Feistel structure, which is Horvath Feistel has designed this cipher, this Feistel structure, how it is working. So as per the Shannon principle of SP network, here see this properly, what is there with you. So Feistel structure is always dividing the plain text into two halves. See this is the basic, or you can say ideal structure of the modern cipher, what you are doing. So the plain text is divided into two halves. So if my plain text bit is 64 bit, so what should be the half of 64 bit? So half of 64-bit is nothing but 32-bit, 32-bit. So always the plain text is divided into two blocks, 32-bit, 32-bit, or whatever the size of plain text bit is there. So if the plain text is 128-bit, then I'm dividing the plain text into two half, which is 64-bit, 64-bit. But we are concentrating currently on DES algorithm. So in case of DES algorithm, the plain text is of 64-bit. So when you're having the plain text of 64-bit, then this 64-bit is again divided into two halves, which is L0 and R0. What is L0? L0 is nothing but W bit, and this is nothing but W bit. And what is W bit? So plain text is exactly 2 into W, means twice of W bit. So if my twice W is 64, then the value of W will become 32. So L0 is equal to 32 bit and R0 is equal to 32 bit. So the whole plain text is divided into left half and right half. Left half is the initial 32-bit, right half is nothing but the further 32-bit. So L0 is nothing but from the plain text, you are dividing the first 32-bit and the next 32-bit. So L0 is first 32-bit, R0 is nothing but next 32-bit if my size of plain text is 64-bit. So Feistel cipher, the first step of Feistel cipher is divide plain text into two half, L0, R0 of equal half of plain text bits. After that, you are having this is nothing but XOR function. So first, what is happening over here is L0 is XORed with some input. Now, from where this input is coming? So see over here that I'm having R0. R0 is nothing but rightmost 32 bit of my plain text. So this rightmost 32 bits are using a round off function with the key you are using this round off function, and then the output of this function is XORed with leftmost 32 bit. So leftmost 32 bit is XORed. Now this is nothing but XOR function. L0 is XORed with 32-bit, but from where you are getting this 32-bit? Because XOR function needs what? Equal number of bits which are taken as X and Y. So X is nothing but L0 and Y is nothing but output of this round off function. So from where you are getting this round off function? So this round off function is taking input as R0 and key. R0 and key. So this is nothing but R0 and key. So this is taken as the round off function. From the round off function, whatever output you are getting, now here you are having substitution permutation pair. You will have multiple S boxes and P boxes. Now this multiple S boxes and P boxes are considered as case of round off function. Now keep this thing in mind that you are having round off function, and using this round off function, what you are getting is corresponding output of Feistel structure, and this is XORed with L0 bit, R0 bit. Now after you are having XOR function, you are exchanging both the bits. So R0 is taken as L1 for the second round. Likewise, there are multiple rounds in modern cipher. So as in case of this, you have seen that R1, Ri, Rn. So there are n number of rounds specified in this Feistel structure. So round signifies that the same functionality is performed for multiple times. So as if substitution, not performed for a single time, but it is performed for n times. So substitution, if it is performed for multiple times, what you are getting is a robust cipher. So because of that, what the single round of the Feistel cipher does, so single round of Feistel cipher, that is taking two things together. So see this thing, that Feistel cipher, what it does. See the steps properly, what we are doing. So Horvath Feistel devised the Feistel cipher using SP network proposed by Klaus Shannon. Within that, you are partitioning the input block into two halves. So the input block is divided into two halves, processed through multiple rounds. You are not having a single round. How many rounds are there? There are multiple rounds. So n rounds are there. We will see in case of DES how many rounds are there. In case of AES how many rounds are there. Triple DES how many rounds are there. So number of rounds are different depending on different modern block ciphers. So number of rounds are different. So this is most important part, that you are having multiple rounds and all the modern ciphers are having different number of rounds. So perform a substitution on left data half. So you are doing substitution on left data half. So here on left data half, what we have done, you are doing XORing. So XORing signifies what? Whatever input is given, whatever input you are getting from what round of function, you are XORing, or you are XORing that with the leftmost beats or left side beats. So when you are doing this XORing with these two beats, whatever you are getting is nothing but substitution. What is the meaning of substitution? XORing. XORing means if 1 and 1 is there, you will get a 0. If 0 and 0 is there, you will get a 0. So that is, you are getting something which is different than that of, if 0 and 1 is there, you will get a 1. So that is, it is doing a substitution on left hand. Using XOR function, you are doing the substitution based on the round function. Now round function is nothing but this f function. This f function is nothing but round function based on the round function of left half and the sub key. Now what is K1? K1 is the sub key, and what is R0? R0 is nothing but right half. So right half and the sub key is given to round of function, and this round of function is input to the XORing function, and XORing function is performed on L0 with that of output of round of function. So this is nothing but substitution of a single round. So once you are getting the substitution on a single round, what you are getting over here, are you getting? So once the substitution is there, the round of function on right half and that of a sub key. After that, you are doing permutation. Permutation means what? Swapping. So after that, you are doing swapping. Are you getting this? R0 becomes L1, output of XOR, that is taken as R1. Output of R1, output of XOR is taken as input for the second round. Second round also needs two things, 32 bit, 32 bit. L0 was from the plain text, L1 was from the first round. R1 was from the, you can say, output of XORing L0 with that of output of round of function. Whatever you are getting, that is exchange, or you can say swap. So whenever swapping is there, it is considered as permutation. Are you getting? Swapping of values are considered as permutation. If I'm having 1, 2, 3, 4. If I'm having 1, 2, 3, 4. Now convert this 1, 2, 3, 4 into 2 half. So if I'm converting 1, 2, 3, 4, this is my plain text. If I'm converting this 1, 2, 3, 4 into 2 half, then my L0 will become 1, 2 and my R0 will become 3, 4. So are you getting this? What I'm telling you, that plain text is 1, 2, 3, 4. So whatever number of beats are there, that is to be halved into 2, halved into half of. So L0 is nothing but, L0 is nothing but 1, 2, the leftmost half beat and rightmost half beat. So 1, 2 and 3, 4. So L0 is 1, 2, R0 is 3, 4. So after that, you are having what? You are having XOR function, you are having round up function, you are doing something, and what is the output of L0? What is the output of L0? Now this is substitution. Substitution means what? Completely the values of 1, 2 and whatever the value you are getting from the output of round up function, that is changed. So just consider that output of this round 1 of XORing will give you 5, 6. If you are getting output of XOR as 5, 6, then you are swapping it. Swapping it signifies what? What is R0? R0 was 3, 4. So L1 will become 3, 4, but R1 will become 5, 6, because output of XOR is nothing but 5, 6. So 5, 6 is taken. So are you getting this? So this is nothing but output of this, which was what? L0 and R0. After that, from the XOR, you are getting 5, 6, and R0 is again remains the same, which is 3, 4. So 3, 4 is taken as L1 and 5, 6 is taken as R1. So now this is considered as permutation. Internally, you are exchanging the beats, you are swapping the beats. So here, these are the 4 principles of Feistel structure. That in case of Feistel structure, first of all, there are multiple rounds. In all the rounds, you have to convert into half beats, left half, right half, and then on the left half you are doing the XORing function, which is substitution function, and on the right half and the key you are performing the round off function. Round off function will have combination of S and P both, substitution as well as permutation. After that, whatever XORing beats you are getting, so those are permuted among R0 and L0. So that becomes L1 and R1. So this is L1 and R1. Likewise, it is given to L1. L1 means multiple round is there. So it is round number 1, which is giving you L1 and R1 as the output. Likewise, round number N will give you Ln and Rn as the output. After that, again, you have to swap these two values. So L0 Ln is taken as Rn plus 1. Rn is taken as Ln plus 1. So 32 bit swapping of both the sides. 32 bit are to be swapped together. So that is nothing but permutation function. Lastly, what is performed? So this is nothing but substitution. Lastly, what you are performing, which is swapping, is permutation. So here, this is the case that this is the whole soul, or you can say summary of your Feistel structure. What you have to do? How many rounds are there? There are n sequential rounds, and all the rounds are performing the same thing. The same thing has to be performed for multiple time, and that depends on the cipher that it is taking how many rounds. So n sequential rounds are there. A substitution on the left half Li. What you are doing is substitution on left half Li. Why substitution? Because you are doing XORing function. So how the substitution is done? So first thing what you have to do is apply the round of function f to the right half Ri and right half Ri and the sub key and the sub key. Now take the XOR of output of 1. What is output of 1? The output of round off function and that of Li. And that of Li. Li means what? R0. So this is nothing but my step number 1, where I'll get the output of XOR. Well, I'll get the output of XOR. The round off function is parameterized by the subkey Ki. So round off function, it is taking input as Ri and that of subkey Ki. So these two things are most important part, that from where you are getting Ki, which is nothing but from the key. So if any key is there, there are two things, plain text and the key. So directly the key is not used. All the beats of keys are not used. But you are having a function which is the subkey function. Using the subkey function, you are having one part of the key. So Ki are derived from the overall key K. So from the whole key K, you are deriving some Ki using some of the algorithm or using one of the function. So this is nothing but your Feistel structure. The whole summary of Feistel structure is looking like this. Now, what are the design principle? Design principle means what? Whenever you are designing any cipher, at that time, we have to concentrate on the principle of that algorithm, whether it is robust enough or how secure the algorithm is there. So how secure the algorithm is there, what you can think about, or what you think about the algorithm is secure or not. So depending on that, there are some parameters. So there are some parameters which are to be considered, that whether the algorithm is secure or not. So as far as Feistel cipher is concerned, it is simply a structure, isn't it? So when you are designing the algorithm from this structure, it is decided that some points are to be considered. That what should be the block size? So increase the size, improves the security. So these are the design principle of Feistel structure, that block size, if the block size is 32, it is considered as very small, the cipher may be breakable. Likewise, increasing the size improves the security. Always, the larger the block, the more secure the algorithm is. But along with increasing the block size, it decreases the slow, it decreases the cipher. The encryption and the decryption process will decrease significantly if the size of the block is huge. Are you getting this? That if the algorithm I'm using is very, you can say, robust, but it is taking so much time, then this algorithm is not considered as a worthy cipher. So worthy cipher, to design a proper cipher, both the parameters are to be maintained. That the size must be chosen in such a way that it should not be breakable, and the cipher should also work fast. It should not be a slow cipher. So choose the block size in appropriate manner, with the speed of the cipher. Likewise, what should the key size? Now, increasing the size of the key improves the security, makes exhaustive search. Now, this is the case that exhaustive search for the key search harder. Exhaustive key search means what? Brute force attack. So if the key size is, just consider that the key size is 8. So how many keys are possible if the key size is 8? 2 raised to 8, because the key in this case we are considering in binary. So only 2 raised to 8 attempts are to be attempted, are to be performed on the cipher text to get the plain text back. So again it is considered as that if the key size is larger, then brute force type of attack, that exhaustive key search attack is harder, but it will slow the cipher if the increasing size improves the security. If the size is increased and the key size is very large, it will slow the cipher. So a lot many R&D is done. Research and development is done on the first cipher which was developed, which is DES. And even multiple version of DES was available, because all these are hurdles. I want to increase the block size, the speed decreases. I want to increase the key size, the speed decreases. What to do, why, or how to balance both the parameter, that was the problem. Likewise, number of rounds. So number of rounds, so increasing the number of rounds improves the security. Always, whatever parameter you are increasing, security always increases, but the speed of the cipher always decreases. This is applicable to all this design principle, all this parameter, block size, key size, number of rounds. Now key generation. Now it is there in the developer hand that the sub key generation. Sub key generation means what? Whether all the bits of key are to be used for each and every round. If I'm having 10 round, all the rounds are using the same key? No. In case of design principle of Feistel structure, it was specified that you should use a subkey generation in which you are having complex keys which are generated from the main key. So complex key which are generated from the main key. Greater the complexity of this subkey generation algorithm, it makes analysis harder, or the breaker or the attacker will not be analyzing, will not be getting the statistical analysis of the algorithm if the subkey generation algorithm is complex, but it will slow the cipher. So you have to keep both the things in mind, that subkey generation algorithm should be robust, as well as the speed of the algorithm should not suffer. Likewise, round off function. Subkey generation function, round off function, both these functions are needed in case of giving input to the XOR function. So in greater the complexity can make the analysis harder. So whatever complexity is there in generation algorithm, it will harden the analysis process, but it will slow the cipher. Slowing the cipher is always there if you want to make the cipher secure enough. So fast software encryption, decryption, and ease of analysis. This was the ultimate goal of the developer. What I want to do, I want to develop a cipher. I want to develop a cipher, but it should be fast. The software must be a fast in doing encryption and decryption, and there should not be any ease of analysis. It should not be easy to analyze the cipher and get the plain text back from the cipher text. So here, these are the cases that in case of Feistel cipher design principle, what you have to keep in mind: the block size, the key size, number of rounds, the subkey generation matrix, the round off function, what you are using, and lastly, the software, what is developed. Ultimately, the algorithm, what we are developing, it should be fast as possible for doing encryption as well as decryption. So this were nothing but Feistel cipher encryption decryption process. We have seen this, how encryption is done: L0, R0, after that key generation, and then lastly after 16 round you are having R16, L16. Output is nothing but ciphertext. Input is given to the decryption algorithm, and what you are getting is plain text back. Are you getting? From the ciphertext, the reverse of all this algorithm has to be done. In encryption, what we have done, the same type of rounds are to be applicable, but here you are doing what? First round which is applied in case of decryption is round number 16, then round number 15, then you are getting round number 1. And from the round number 1, what you are getting is plain text back. So plain text back you are getting from decryption using decryption process of Feistel cipher. Now DES, before starting the DES, it is already 11:17. As I told you that today I'll take test. Today I'll take your test of second chapter. So meanwhile, are you getting this? So meanwhile, I'll give you the assignment, and this time the duration of this test is 15 minutes. The duration of this test is